Okay, we're really live now. All right, so welcome to Python 101. This is the culmination of sort of a lot of the foundational stuff that you've been learning in SQL and Tableau with a lot of data visualization, obviously. So yeah, we're going to discuss sort of having that understanding and using that to sort of drive better decision making within a business context, which obviously is business intelligence. But that is sort of a subset of the larger data science. So we're going to touch a lot on sort of the more broad points of data science in this, but I'm definitely going to need you guys to sort of, in terms of what you're looking for, maybe where you work now, like the questions that you have that can help you do that job better, or just if there's things that you want to know as we sort of get into this stuff and it sort of hits your brain, feel free to like bring that stuff up. That's what is going to drive my curriculum, is the things that you guys want to do. So this first course is going to be largely a sort of outline of all the things that we have, and then sort of based off of like what I hear from, you know, the folks online and y'all here in the class, I'll sort of tailor the curriculum towards those types of things that you guys are looking to learn or get better at and whatnot. So yeah, that's what we're doing today. We'll go through introductions first. I'll kind of go through expectations of the class, get into a little bit more what I was just talking about, overview of Power BI, not Power BI, excuse me, business intelligence and data science. And then we'll get into what's hopefully going to be a review for a lot of stuff that you guys have already done. And then we'll get into some Python today. Specifically, we'll be working in a cloud environment, so no one should have any issues with operating systems and things not installing, because we'll do everything within the browser. Everything can run everything themselves. And then as sort of the class progresses, I might work with you guys one-on-one to make sure we can kind of get those Python environments set up, because it does sort of differ from computer to computer. And I'd like a consistent experience when it comes to that stuff. So yeah, hopefully everybody got into the deep note. I don't really do slides. I don't really like slides. I don't really like that you sort of just have somebody captivated on the same words for a long time. So this is more of almost like an article is kind of how I have this stuff written. I'm not going to read this word for word, but it is there for your sake. And then obviously I think the really cool part of this is when we can get into Jupyter notebooks and start actually coding and doing some of that fun stuff. So yeah, my name is Tom Flaherty. I am 38. I've been working in the tech industry for about 13 years. I started out doing visual design and then moved over to user interaction design and kind of strategy behind that. And the deeper I got into that, the more that I realized that if I wanted people to listen to me, it wasn't like, this is red and it looks good, or we think these colors mean this. It was like, if I could have actual data to back up my decision making, then no one could say no to me. So rather than going to art school, I got my associates from MCC here. I went back to school for mathematics. And I was lucky enough to be able to go through a full undergrad in mathematics and then my master's in mathematics with a data science concentration. I don't really recommend that anymore these days, unless you really like math. If you like math, then totally do that. I adore math. I love math. So it was really cool and fun for me. Pardon me, I'm getting parched. So yeah, pretty much starting my graduate degree, I had a full-time job here in Omaha at Methodist Hospital, where essentially their analytics was super old. And they needed people to figure out how to do the work and bring them new tools. They wanted to do it inexpensively. Python obviously is open source. We used a lot of R as well. Specifically, RStudio was sort of kind of like the foundation of a lot of the stuff that we set up there. That team that I helped like essentially put together still operates with my old office mate as their manager. And so, yeah, that was cool. I did that sort of in tandem with my graduate studies. I did a whole sort of thesis dissertation on understanding opioid prescribing and trying to find prescribers that were overprescribing, because that's why people were dying. And so I did a bunch of visualization and analysis around that, and that was my thesis. That was great, but I mean, the grass is always greener, basically. And I jumped to another hospital. I went to Nebraska Medicine, UNMC, worked as a senior analytics developer there for about 2.5 years. And it was a lot of the same. It was a different electronic medical record or electronic health record. If anybody works in health, I think some of you guys do healthcare. Some of the folks online, yeah. So I'm familiar with Cerner and Epic. I didn't much like Cerner. Epic was good because there was documentation, but it largely, I found out that EHR data is not for me. So when the pandemic hit, I helped do inpatient census forecasting. Basically, the hospital needed to know when they were going to hit max capacity, but they also needed to understand staffing. So if they knew a lull was coming, they could staff a little bit lower and not burn out the nurses and the doctors, because that was the issue they were having at that point, was they couldn't find enough people to work. So I did a lot of work there, worked with the academic side, the UNMC side, to put together, we were essentially trying to figure out if we could take the testing data that they were doing within the hospital to try to figure out test positivity, and then sort of understand how that works from a differential equation standpoint. So if we could understand the rate of transmission at a given day. And this was better than the state was doing at the time, because at the time the state was doing these calculations from the Test Nebraska data, which was all statistically wrong, because all of these people were going to get tested who thought that they were sick. So statistically, that's not a sound sample that you can derive test positivity. You're going to have an inflated test positivity from that, and it's not going to be indicative of the actual community or the state. So I said, if everybody that comes into the hospital gets tested, that is more of a random sampling of our community. That is going to be a better sort of metric to try and understand the transmission within the community. So that was good. That was a big hit around there. So that sort of got me some money over there as far as buying some data science infrastructure. They invested in RStudio Connect, which obviously does R, but it also does Jupyter notebooks and stuff like that. So we were able to sort of stand up a pretty robust system that they're still using. But once again, grass is always greener. Like I said, I didn't really like EHR data, so I jumped ship and went to a place called Spreetail, which this used to have the logo on, but I scraped it off because I got laid off in October. That said, Spreetail was cool. I got to work with really cool toys there. I got to learn a lot about Apache Spark and Databricks, which is sort of like using that stuff in the cloud is so much faster than you can imagine, like on like your regular machine. If anybody's ever messed around with anything Apache Spark or anything like that, it's super fast. So they essentially said, here, figure this out. No one knows how to use it. And so I figured it all out. And so that was a lot of fun, spinning up clusters to do what was taking their old forecasting group 28 hours, took me 45 minutes. So I was able to really sort of like stop the spending that they were doing by spinning up big clusters, and then put in place practices to really utilize Apache Spark and serialization and distributing computing and stuff like that. And I thought I was going to be at that job for a minute. So that's a lesson that I learned, is that sometimes the tech industry has its ups and downs. So I was laid off in October. And then I quickly found a spot at Buildertrend in mid-December, with a lot of help actually from Nate Watson. So yeah, now I am there. I'm focusing more on their data engineering solutions. Buildertrend is amazing because they give a lot of money to data science, to the analysts, to the business intelligence people. And while that's cool in theory, if you don't have the data infrastructure to support that as your business scales, suddenly all your data science people are putting out fires all the time. And so that's nothing, hindsight is 2020. You can't, when you're putting out good stuff, and because of that, your place gets bigger, you sort of, you don't know what you don't know. So I am now on that team. I'm a staff data engineer, and we are kind of looking at things from a newer modern data stack. some of you might be familiar with on-prem stuff when you have like a server room and it's huge and they have like bronze, silver, gold tables, and they don't want any sort of replication. So like your SQL is like crazy because you have to join to all these tables. Well, with cloud data, suddenly it's like this stuff is dirt cheap. We don't need to worry about any of this stuff, on-prem stuff. We don't need to worry about space. So now data engineers are really free to sort of build data warehouses that facilitate more to the business rather than limited by the technology. So it's cool. We're doing fun stuff. I'm learning a lot still because obviously I've been in more of the machine learning, data science world. Now I'm understanding more of the data engineering side with the hopes of laying down something that's awesome that I can then build an enterprise modeling solution on top of. So more on that when I do it. Yeah, and then through getting a job, talking to Nate, Nate and I hit it off really well, and he asked me if I would teach this class, and I said I would love to. My mother is a teacher, and when I told her I was instructing a class, she was thrilled. So this is for my mom too. So yeah, I mentioned, some of you saw my bike and asked, I rode my bike here. I don't own a car. Well, my wife owns a car and I helped buy it, but I don't use it. And we have a 16-month-old daughter named Mary Frances. We call her Effie. She's the coolest thing in the world. And I thought math was really cool. And then I watched a human develop, and now that's the coolest thing in the world. I also do a lot of music. I started off singing in barbershop quartets and playing guitar, and now I'm all electronic. I have hardware sequencers and stuff and big suitcases, and I'm playing a show tomorrow actually in Benson at the Pet Shop. I'm opening up at 8 p.m. if anybody's interested. Other than that, I love video games. I bartended for a good half a decade between sort of the visual portion of my life and the data portion of my life. And I love Legos. Let's get on to what class is going to be like. I kind of talked about it a little bit, but I do kind of want to, I don't mean to put people on the spot, but like I sort of mentioned earlier, I want to tailor this class to what you guys are interested in. And it's okay if you don't know that right now. Sometimes you don't know that stuff until you see it, and then you're sort of like, that's the thing that I want to do. So I wouldn't mind kind of going around and getting intros from everybody. I've been talking for a really long time, and I haven't done that in a long time, so my throat kind of hurts already. So we'll see if I can last another 2.5 hours. So let's see here. I think I might start with the folks online, if that's cool. I'll mute myself. Ted, is that okay if I start with you?
Sure, why not? So my name is Ted Ottenheimer. I work for a company called Ascom. Been with the same group in the class. This is our third class together. And it's been a lot of fun doing these data courses and analytics courses, and of course, data viz. So we are a medical device manufacturer along with software. We do clinical outcomes as far as it goes with consuming of a monitor and medical device information, and then we send them out as events to mobile devices, which helps speed up the delivery of care and clustering of care, things of that nature, all those key things that you probably looked at in your day. But my dream has always been to put some analytics behind it instead of reports, right? Nobody likes a report card. A report card is just very basic, and hence my reason for studying data analytics, so that I can help interpret what I would like to see. So just an immersion into it, and from there we'll see where it goes.
Awesome.
So that's kind of my expectations.
Cool. Yeah, that's great. I took some notes on that. I really want to help you out with that. I think I have some good ideas to sort of maybe get some examples of things that are reports rather than like analytics. And that will be something that I think a lot of people might find interesting. So appreciate that, Ted. Looks like somebody else. Oh, Rochelle's in. I'm going to add. Oh, there's other people in the stream. Wait, Anna, you're in here, right? Okay. Gotcha. I'll add Rochelle. Okay. James, is it cool if I call on you next?
Yes, sir, it is. I'm James. I too work for ASCOM with Ted. I I do installs with our software that we sell. So, and I also install the hardware. So yeah, I'm definitely interested in this class for not just for work reasons, but for just personal learning reasons, things like that. I've taken like a intro to Java course and like the other coursework at my university I graduated from. But like if it's anything like that, I'm definitely interested in what the class has to offer. Um, learning goals. I don't know like the learning goals yet. I'm just interested to see how it applies to like data science and things like that. So I'm just looking forward to learning.
Cool. Yeah, that's like I said, that's a totally relevant answer. We're getting into stuff that maybe you've never seen before and you don't know what you don't know. So hopefully you see something that piques your interest. And again, always feel free to, comment or hand or holler at me, tell me to shut up and we'll talk about that stuff. So really, really excited you guys are here. Charity, can I call on you next? Oh, I'm looking at everybody in here and I'm like, where's everybody at? Okay. Yeah. All right, folks online, Charity's going now. Is that cool? All right.
I work for Wells Fargo. Well, hi, I'm Charity.
Cool.
And actually, I've heard of Python, but I've never taken Python before, so I'm kind of interested to see what you guys
Cool.
I'm really excited. And
What do you do at Wells Fargo?
I am, they call it now a branch operation manager.
Cool. No, not at all. If that's all you got, that's all you got. Again, I'm not trying to put anybody on the spot here. I'm just trying to, yeah. So yeah, interested in Python. I think as we I'll try and get through this stuff so we can get to the cool stuff. Nate wanted me to sort of skip the first class because you guys have done a lot of that and get more into the technical stuff, but there's still some sort of like this stuff we got to go through, but yeah, we'll totally get there. Cool. Anna, you're in here. So I'm gonna go with the other online person. Rochelle, can I call on you? Is that cool?
Hey everyone, my name is Rochelle Walker. Sorry about my tardy. I was actually in the first link and I sent a comment like, hey guys, I've been sitting here for a while. And I scrolled down in Slack and I said, oh, okay, that he uploaded a second link. So I apologize for my tardy. I work at MUD, the gas and water company here in Omaha, Nebraska. I have a little bit of experience with SQL, none with Python. So I'm really excited, to take this class. I'm not really sure what to expect or what I want to get out of it because I'm really, really new to Python.
Sure.
But yeah, just happy to be here.
Awesome. And I'm sorry, I missed that. Where did you say you work again?
MUD, the gas and water company.
Awesome. Cool. Great. Looks like we got somebody watching. Marvelous. I think somebody's just watching the stream. Hey, I think so. Yeah. Well, hey, Marvelous. Currently viewing from Nigeria. That's insane, my man. I think my person. Yeah.
Might be Nate.
Oh, is Nate trolling us? Well, whatever. I'm going to continue on like I have a viewer in Nigeria because that's amazing to me. That's seriously unreal. Okay, so Anna? Cool, yeah.
So I currently work for UNL under College of Arts and Sciences within called the
Cool.
Yeah, and I currently am the program coordinator here for Omaha. We put together websites for people who are low income to moderate income, and we do their taxes for free. And we also do international taxes for non-residents.
Awesome. Cool.
So then tomorrow is our last day, and then I get a whole week off.
Nice.
Sunday.
I'm doing this in tandem with like some other sort of like personal music stuff. And then when that ends and this ends, then I'm also taking like 3 days off to play video games and hang out with my daughter. So
I'm excited for my days off because we've been like back to back to back for like the last month.
yikes. That's
So
crazy.
it'll be fun. And then, what did I do? So my job requires a lot of things among like analyzing what we've done for the season. So that'll be our next thing after we come back and take our break. We'll start looking at all our figures. What did we do? How much did we do? How much did we get in like credits? We'll divide up the credits to see what we got for each. So like child tax credit, I don't know, earning credits, stuff like that. I don't know Python. I've heard of Python. I think I downloaded that once, this like random app game thing. I
Okay.
got to like level 5.
Cool.
And it was very basic, but you like keep going through it.
Yeah.
So, yeah. And then, as far as where I want to work, I do eventually want to switch from what I'm doing, especially I actually like it. The pay is where it's not at. So I eventually want to get to some place that actually like gives me more of what my work is worth. And I do want to do a little bit more of like data analytics. I don't know what that would look like though.
Right.
I don't know, I guess where I.
Yep. I mean, you're going to hear me say you don't know what you don't know a lot, because it is so true in this area. And that also applies to the people that you work for. They definitely don't know a lot of this stuff as far as like what's feasible. I've had issues with that in the past where my managers can't empathize with the work that I'm doing because they don't understand it. So even if you don't necessarily go on to do Python from this course, I hope that you can kind of understand a little bit of the sort of mindset that you need to have to do that stuff. And if you see somebody doing it and they're going through like a rough patch, you can kind of be like, okay, yeah, I get what's going on. So, and then Brenda, right?
Yeah.
Cool.
So I worked at the state of Nebraska, it's under Department of Education, but it's an agency called Nebraska VR for vocational rehabilitation. Reality. I work with disabled individuals, in just for different ones. I go to high schools, and transition sites. Obviously, it's really to do with data. What intrigued me about data is to get myself way to like how we could actually use that to help us. I came to the realization that that's not going to happen anytime soon. Like just being the state,
Right.
We're just like 20 years late. And so the idea behind it is that maybe I can go venture out elsewhere. I don't know what that looks like.
Sure.
I did take a Python class. I said I run all the time.
Mm-hmm.
Through like Stanford Code in Place.
Yep.
program.
I'm familiar with that.
And I liked it a lot. One of my, like, she's considered like a tutor, said that I'm a natural problem solver, and that's one of the things he did with Python, was that he's like, you have already like, find like secure ways of like, if this happened or with this, like, how do you do that ahead of time to practically like, make that solution no
Yep.
longer relevant. So I like that. I also had a baby by that time, so I also was rushing through some things that I wish I had more time, and I didn't think that was hard.
Yep.
So my goals with this class is for me to have something where I can show them what we get, or there's other sorts to show them like what I think we're learning from Python, like that my resume.
Awesome. So you just touched on probably one of the most important things that comes with the sort of mindset of like when it comes to Python and coding in general. And then further down the line, data science, is it comes down to problem solving. That's what is the difference between doing something that has been around for 50 years and we know how to do it and nothing has changed and it's muscle memory. With data and analytics, a lot of the times it's using the critical thinking and problem side of your brain to figure out, I have data like this, it needs to be like this so I can use it to show this. And Python is the sort of the jack of all trades that can do all that stuff. So if your brain can start thinking like that, then you can start building stuff like that. And that is, I mean, that's why I like this career, is because I love problem solving and critical thinking. And I like to see that in other people, but also like that's sort of like the fuel for me to like continue on. If somebody else thinks of something and I'm like, oh, that's crazy, how did you think about that? And then I've got that now, and then all of a sudden I come up with something different. So education in general is obviously huge for me and stuff, and just that mindset of problem solving. A lot of instructors that I've worked for or that I've had in the past call it hacking, which I think they use that as kind of like a buzzword to sort of like get people like thinking it's cool, like, oh, we're hacking. It's like, no, you're just problem solving. Like, that's how I've always felt it is. And I think that that's a more glamorous title. I don't think hacking is any more so. I don't think you want to be associated with that at all. So cool. Well, that's awesome. I think Marvelous is still here from Lagos. Am I saying that right? I think so. That's amazing. Cool. Well, Marvelous, I mean, you can't talk back, but you could certainly leave comments if you have any questions. Okay, yeah, let's keep rolling here. Sorry. So again, these are the slides. They're not really a slide; it's just a big thing. I'm pretty sure you can download this as a Python notebook, which I will show you how to then open those and sort of use this and have it if you ever need to reference it. We are going to do some stuff in Anaconda Cloud. Are you guys familiar with Anaconda? Have you ever heard of that before? So Anaconda is, you can, what? Oh yeah, I know. Oh, yeah, okay. They should have music playing in the background. Yeah, so we're going to do that. It has a great virtual environment that we're probably going to max out. Like as we get into that, you're going to see like your CPU usage go up. When we'll cross that road when we get there. And that will sort of bring us into kind of using the actual Anaconda installer locally on your machines and getting environments up and running there. And then that's really nice because if you ever break your environment, you can just trash it and make another one. It's super simple. There's not a lot of command line stuff, which we're going to talk about in a little bit, but yeah. And yeah, you're not, like, I guess I try to keep saying, like, I'm not expecting you guys to like put together like an amazing Python application that you deployed and it's in the cloud and you can hit it from your phone and get predictions back. We're not, I mean, yeah, that stuff is totally possible, that you can kind of see the breadth of what's possible as we go into the stuff, but I'm not expecting anybody to be a wizard at this stuff. So like, don't worry if things aren't making sense. For me, Python clicked after about 2 months, and this is like a 4-week class. So if you've seen it in the past, it might click a little quicker, but don't worry if it's not making sense. Again, all the stuff in Anaconda Cloud you can run and you can kind of see how that works, and you can always reference that if you need to. And again, yeah, ask questions, stop me, especially if I'm rambling. Yeah, so let's go into the sort of crux of this class, which is the overview of business intelligence. I sort of summarized this earlier, so I won't get too into it again. But understanding SQL and relational databases and sort of being able to visualize tabular data, which tabular data is just like if you open up Excel and you just see like a big grid, like that's tabular data. 2D array is what Python purists will call it. Those guys are nerds. Don't listen to them. It's a data frame. That's more acceptable. a data frame is good. And it is just it's a big, huge grid of data. Depending upon what your granularity is. Are you guys familiar with granularity? Have you heard that before? Like, so each row if let's say you've got an Excel doc open or you have a data frame open in Python, each row is going to be an observation that merits something. So for those of you that work in the medical industry, like think of it as like each row is a patient. So we have row 1 is patient A, here's their blood type, here's their age, here's where they were birthed. So understanding like data from that point of view of like what is it really saying? That's sort of data literacy. That's what SQL is all about, is understanding that level of what the data looks like and whatnot. And then having that understanding says, oh, I want to take everyone from this medical data set that is above the age of 60 and look at like their blood pressure and then compare that to other age gaps. Now we're starting to get someplace. Now we're starting to compare age groups. We're starting to see, is there correlation with age and blood pressure? Now we can go to Tableau and we can do visualizations of this. And now you can present this to someone and say, we need to look at our elderly population that's in the hospital right now because their blood pressure is going up. That's probably not true, but I'm just saying that's the sort of things with understanding data at that granular level and saying, I can look at it from this point of view, summarize it here, and then visualize it. That is the power of visualization and understanding SQL. And so the Python side of it is now we have one place where we can do all these things. You might need to do a little bit of SQL to like get your data right and whatnot, and you might like end up delivering a Tableau dashboard because that's what the stakeholders want. But in general, you're doing a lot of your analysis within a Python notebook, and you're running potentially statistics. We'll touch on that in later classes. And so that's where a lot of you have talked about, I don't want just the numbers. I want to show the meaning behind the numbers. I want analytics. I don't just want reports. I don't want an A for this month. I want to understand the trend of my grades for the last 12 years or whatever I was doing in high school. That's the stuff that we're going to get to in this class. Pardon. Cool. So there's a little, in the slide here, there's a little code spot that says print onto the good stuff. So this is some Python. You can actually, is my thing's probably not running? Okay, whatever. But this is a little Python script. This is sort of signifying that we're moving on to another part. So let's talk about command line. And where are we at for time? Cool. We're going to probably get through this and take a little breather, I think. So command line, according to the syllabus and according to Nate, this should be a little bit of a review. Have you guys heard of this command line before, or is that brand new? It's brand new? Okay. I will pull up the command line and show you what it looks like. Oh, whoops. Let me do this. Yep. Ooh. Sorry. So command line is kind of like driving a manual. Like, we have things that do everything the command line does that is way easier to use. But sometimes you've got to go in there and do stuff. But the command line stuff is super old. This stuff has been around forever. Anybody that runs on Linux, I don't think anybody's running Linux in this class. But if you are, you're probably more familiar with the command line to get your stuff set up. You pretty much have to do that. So yeah, I have some info in here about what the command line is. And actually, there might be, I was hoping I could do more interactive stuff with this deep note stuff, but it doesn't look like it's as interactive as I want, which is why we're going to do the cloud stuff. But the command line is where a lot of stuff is happening behind the scenes because of the things that like our new software can do. But you can do a fair amount of like launching. Like, so I do a lot of things in what's called DBT, which just stands for database transformations. All of that is native command line stuff. So I'm just writing essentially SQL queries at the command line. But I have a program that does that for me. So it's good to know what this is. We can do some stuff. So here I am currently in, looks like I'm in my regular folder. So let's compare this to my HD. Oh no, it might not even be that. Music, pictures, users. There we go. So this is pretty much, yeah. So you see sparkling water right there. You can see that reflected there. This is the folder that the command line is in right now. So it is literally like an old school way to traverse your computer if you want. If any of you are familiar with like MS-DOS or something back in like the late 80s, early 90s, that was also a sort of command line. And so you can do things in here. If I want to move back, so we saw earlier that there's another folder behind this one called shared, and then there's mine. So if I do CD, which I believe is called directory, ... Now I'm back in users, which is this one. So if I use the command ls-a, that's going to show me everything that's in there. And it's also going to show me, so we see shared, which is right there. We see my folder, Thomas Flaherty, which is right there. But then we see this .localized. So this is even, command line stuff is even going to show you hidden files that are in folders, which, you know, is pretty tricky if you get to the point where you're needing to mess around with hidden stuff. But this is what this is. Some people do data science and they do Python from the command line. So I'm pretty sure I have it on here. I think I can just run Python right now. Yeah, so I am now in a Python session in my command line. So I can say x equals 1, 2, 3. So I've made a list and that's defined. And now I could say print x, and there's my 1, 2, 3. I'm not going to do hello world. That's what everybody else does. And so, yeah, you can literally do Python at the command line. But again, this is akin to, this isn't even a manual. This is like horse and buggy. Like this is like, well, no, that's not true because it's very powerful. It's a manual, I guess I would say. You can do a lot of cool stuff in here, but there are more elegant ways, in my opinion, to do stuff. If you do want to mess around with the command line, but you don't want to mess around with it on your computer, you can go to Google Cloud Shell. I don't know why. There we go. And then there's a little activate Cloud Shell. This will launch everything, and now you can mess around in a virtual command line, so you're not going to mess your computer up. This is sort of similar to a lot of the stuff that I'm going to be talking about is how do we mess around with these things in a virtual setting so we're not doing anything to our machines. So you have this if you want to mess around. And so similarly, let's do our ls-a command. We can see in this one, I have a bunch of stuff. This is at Google Cloud Shell is legit, but to make it super legit, you do have to pay for it. I think I was looking because I wanted to do the class in this and it was going to end up costing like $40 a month for everybody, which is like not feasible, obviously. I am talking to Nate about figuring out how the curriculum of this course could potentially get to this at some point. But yeah, so that's Google Cloud Shell. You can totally mess around in that. And it's free to a point, but they never ask for your credit card. So when it's not free anymore, it just stops and you're like, cool, peace. So yeah, we went through kind of some of this. So if you're on a Windows machine, it's CMD or command. It's going to be like the old school command line. It's the terminal version. On Mac, it's called terminal, even though the thing itself is called terminal. That's why there's a question mark there, is because I'm not sure why they named it that. Then PowerShell is sort of like the updated command for Windows, which is super powerful. I did a lot of stuff in PowerShell when I was at Nebraska Medicine. Linux is Bash. And these are kind of all interchangeable as well in terms of like, some people will say like, oh, run a bash command in your terminal on your Mac. And it's like, I mean, Mac is technically Unix, which is an offshoot of, so yeah, anywho, now that I've thoroughly confused everyone, there is also a fair amount of IDEs where you can run a command line. So I'll open RStudio real quick and show you what that looks like. It opens, there it is. Yeah, so RStudio is similar to Jupyter Notebooks. So I have things I can run in here, but also here's my terminal. So like we do, let's run our LSA command and see where we're at. So we're in, it looks like we're in one of my documents folders where I have some stuff. Yeah, so you can, again, you can run command line stuff from multiple places and multiple programs. And yeah, again, it's not super necessary for the stuff we're doing, but it is good to know. Yeah. And I think that is a good stopping point for right now. We will go through version control pretty quickly next. We talked a lot about data management, talk a little bit about data manipulation, and then we'll try to get to some Python after that. Cool. So I'm going to try and figure out how to do a timer on here. I don't know how to do it. Yeah, that's banner. Break time. That's not what I want to say. How do I change it? Break time, please be back. Let's go 7:10. Is that cool with y'all? All right. Is it going? Show. Yeah, I did it. Cool. And yeah, folks online, feel free to hit me up, voice on this, or I'll have Slack open too if you want clarification on anything. And yeah, folks in the class, feel free to stretch legs, bathroom. I think coffee shop is closed. I keep looking at that Traveler. Is the bottom all wet or is that?
No, it was a coffee.
I thought it was like drastically leaking, and I was like, oh God, I'm not going to clean that up. You guys know if there's water around here?
Yeah,
anywhere?
if you go out from there, go to the right, there is, go to the restroom, there's.
Gotcha.
So the men's restroom is straight through.
Yes.
But take a right, and then there's a water, that one that you can just,
Nice. Oh yeah, what's in there? Nice. I think I might do one of those. I need to turn my, I don't know why my Slack notifications are turned off, but I keep like, Nate knows he's fired now and I missed that notification. Here we go. Ah, now we're good. Shadowcast. Where is it? That's a bummer.
Does that outline water or no? It does have outline. It tastes like not fragile, so we're like very distinct taste, no?
Yeah, it's good.
Yeah, that's what that but it's almost out.
Yeah, they only sell it at QT.
Oh, really?
Yeah, they only sell it at certain gas stations. And then you can buy it in bulk plus around later.
Like one of the Costco workers.
No, it's been this or recently for Sam's, I don't know if I have it there. But every once in a while, randomly, one of the Walmarts will have something. That is, it is.
What's it called?
It's Hawaiian.
Yeah, it's Hawaiian.
Oh, cool.
It's Hawaiian authentic water. It's delicious.
Nice.
People always tell me that water doesn't have flavor.
That's not true. I saw this docuseries with Zac Efron and I don't know, it's on Netflix.
I think it's heard about it. I didn't watch it.
It's talking about like the different kinds of water. And at first I was like, this is supposed to be a joke because they were talking about like connoisseur for water, and I was like, who the heck is it? Whatever. Now that I've been like looking into like, oh yeah, there's like a huge difference from what you get. I usually drink tap water. I'm not like picky.
Mhm.
In my culture, you can't be picky. But now that I've like tasted alkaline water, I'm like, oh, I can see a difference, and I do see like my body does feel differently, and so, but it's also expensive.
I'm not picky, but I can tell. If I get the option.
Yeah.
So I went to high school in Grand Island, Nebraska, and that's where a bunch of my family still lives. And I never like thought anything weird about the water until I moved here. And then when I went back there, I was like, the water tastes so weird. I found out that they have like a high concentrate, still acceptable by FDA, of uranium in their water, which it is.
Yeah, because I mean, when I go visit her, I usually get water from on like the bottled water, they don't drink from the tap, and that's the water I get too.
My brother's wife, for the longest time, she'd never been farther west than Philadelphia. Like, so she lived in Vermont, and like that was it. And she married a Nebraska boy. And yeah, the first thing she noticed when she got here was just like, the water tastes absolutely terrible. And I was like, it does taste bad. I never noticed. But
Yeah, when I found this water had a different taste. I had actually we had gone to this meeting somewhere in Texas, and they had the well water, like water fountain with well water. It was the best water I've ever tasted, and that's when I realized that water does have flavor.
yeah.
And I'm like, I want to go back to see the water bottle full of water again. You know?
All right, we're just about there. Oh, more comments. Nice.
Is it Marvelous?
Marvelous he was still with us at 6:58. Oh no, I'll leave now, but I'll try and be back. It's almost 1 a.m. here.
Full comment?
That's what he's saying on StreamYard. Whoa. But yeah, that's what he's. Yep. My first fan.
This never happened to any of our classes.
Yeah.
Weird.
No, yeah, it was either, I think it was Charlie in the first one or the second.
Oh, yeah, I think I remember.
Yeah. Yeah, but he, like, actually left immediately, like, the first hour.
So that's what he mentioned it.
Yeah,
That's.
We had a viewer, that's like.
I've like thought about getting into like streaming, like, because like my music setup is pretty cool. Like it would be like, I got a decent amount of followers on TikTok. Don't get me wrong, but I've like thought about getting into like, what's that? Oh, in Wyoming, right? Or something. Maybe Montana or something. Yeah. I don't know how they can. I mean, you're not wrong.
That's where I got that, but it's been. Yeah, Instagram too, that's why I think I sent it to my cousin, but she's so addicted to TikTok. I'm like, look, they've been to do on stage. I don't know TikTok.
Okay.
I'm already addicted to Instagram, so.
Well, we're going to talk about something way more boring than that. Version control. Who here has heard of version control? Is that something you guys have? Oh, here comes somebody. Oh, he's just checking. We're locked in. No, I'm just kidding. Okay, so we're back from break. We're going to talk about version control kind of very briefly. I don't think we're going to touch on that stuff too much because, again, this sort of gets into the way more technical engineering side of things, but it's still very good to know. Have you guys ever heard of GitHub before? Yeah, so GitHub is probably the most popular one. That's actually what we use at Buildertrend, which I was like surprised about just because it's like an open source thing. We use their enterprise version, and it's great. And so it is essentially like if let's say we're all working on a big machine learning model together and everyone's amazing coders and we're all taking different parts and I'm doing the pipeline and somebody else might be doing the gradient boosting and stuff like that. The idea is that we can all work on this thing separately and then push our changes to the main sort of version of it And when we do that commit or that merge, whomever is sort of the head in charge of the project can look at the code, and it's sort of like you're making sure all the pieces fit in. And if something doesn't fit, then we can go in and change it. Or if something completely breaks it, we can roll back those changes. So it's sort of a way to sort of iterate in engineering and machine learning, data science, and analytics. So I have, this is the sort of list here. I have the, yes. James. Oh, geez. A bunch of people did. Are they in? Why did I not get that notification? Where did he say that?
On the chat window,
Oh, private chat.
Please forgive me, James. I'm new. Okay, sorry about that. James, we're talking about control. Are you back in?
Yeah.
Awesome. We were talking about version control, and essentially it's sort of like, I'm going to use Legos because I love Legos. It's like everybody's building a different piece, and then when we're getting ready to put it all together, we're going to look very closely to make sure everything lines up and fits together perfectly and looks good and works the way it should. So like a typical workflow for me at Buildertrend, somebody might have some sort of a data pipeline. So they're sending data into this pipeline, and the pipeline is doing some cleaning, maybe like doing some text cleaning. Maybe there's like some weird capitalization stuff going on. Maybe some of the numbers were entered as characters. So those need to be converted to some sort of numeric or float. So this pipeline is doing all this work, and there's a portion of it that needs, there's a portion where a string needs to be split into 2 columns. So I need to write some SQL to look at that and say, 5 characters in, I want you to cut that off and turn it into a new column. So I'm going to go to this repository on GitHub, and there's a clone from source button, and you hit that. Now it's going to download everything locally to my computer as a new branch. So it is literally like a tree. It's like, now I've branched off from this. I've got this new part that I'm building, leaves, if you will. And so I'm going to make all those changes locally, and then I'm going to commit that back to the main one. But I can't just like haphazardly throw it in there. People need to look at it. The person that's like writing the whole thing needs to make sure, again, all the pieces fit, all the code makes sense. There's code comments. That's a huge thing we'll talk about as well as we get into Python. And so that person is then that's called a PR or a pull request. So I've pulled this data. Now I want to merge it back. And so that sort of gets into the last bit where we look at everything. Any changes are made. It's approved, and then we merge the new branch in. We have everything working in the main branch. And so the old branch still exists, and so we delete it, but Git is cool because like it keeps stuff up to like, you can like tell it how long to keep deleted stuff. So let's say that we make an assumption for a particular branch that I've merged in, and that assumption drastically changes. We can just roll back to the one that worked, and now we're good to go. So that's why version control is clutch within an engineering environment, especially machine learning, data science, and stuff like that, is because when things break, we can roll back and get things working again. Talked about providers, GitHub, obviously. GitLab is what I used at Spreetail. That's also what a lot of UNMC used when I was doing some work with them. Bitbucket, I've noticed, is another one. And then the worst one of all is Azure DevOps. If you ever have to use it, I'm sorry. It's Microsoft. Microsoft even owns GitHub, and yet they have Azure DevOps as like another version of that. It is what it is. So Git is initially all done at the command line. So if you go to the link in here, you can see sort of what this stuff looks like. I think I can run it in the terminal here. I think I can run Git. No, it's not active right now. But this, if you downloaded this right now on your machine, you would have to do all of the merging and stuff like that. You'd have to do that at the command line. And again, hardcore coder and engineers love to work at the command line. That's what they do. But for the rest of us, we can just use, I don't have GitHub Desktop on this machine, do I? I don't think I do. We can use GitHub Desktop. Also, IDEs have their own. So here, let's see if I can, whoop. Pretty sure I can push this version control, project setup. So yeah, I could do it in here right now if I wanted to. So I wouldn't even need to use the command line. I could do everything from whatever IDE you're using. And we'll talk about VSCode. That's the one we use at Buildertrends. That you can do everything. You can do Python. You can do SQL. You can do DBT. There's Spider is another one that a lot of Python users like. PyCharm is another one. RStudio can do both Python and R, which is kind of cool. And yeah, you can do all your Git commits and stuff from here. Actually, there it is. Why can't I push this? Okay, whatever. So we'll go back here. And some fun Python again. All right, so data management and data manipulation. I sort of touched on this earlier about sort of being able to visualize and understand what your data looks like and understanding at that sort of granular level. Remember, we talked about the patient. Each row is a patient. That could be a bunch of other things too. At Buildertrend, for instance, right now, actually, maybe I shouldn't say this. Well, I'll say it anyways. Right now, Buildertrend is trying to figure out how to, they have more than one product. They have the product that is their big one, which is essentially a project management application for home construction workers. I'm not using the right terminology, I know, but it's for people to like, rather than using pencil and paper or Excel to figure out what they need to build this house, we have this program that will guide them through that. And so that's a customer for that product. But we also have other things, other products that do just pricing on those things. And then there's, we acquired this place called CoConstruct, and there's people on that. And so one of the things they're trying to figure out right now is rather than looking at like Builder ID, CoConstruct ID, all these different places, how do we have just a universal, you're a customer? Like, you're just a customer for what we do. So that's something that they're trying to implement right now. But that gives you a good idea of like understanding data at that granular level is like, what is our data at that sort of line level, and what are we trying to accomplish with it? And so, yeah, for right now, for Buildertrend, trying to combine all of their different customers into like a universal customer ID is something that we're going through right now. And that is data management. And so, yeah, I touch on some stuff here. Data collection. People talk a lot about like, oh, I'm scraping the internet for this stuff. And there's a lot of scrapers, but there's also people on the internet are getting smarter, and it's harder and harder to scrape websites. So we might touch a little bit on that, but it's not. Data is more readily available now than it was maybe 5 or 10 years ago. Data storage. I talked about this earlier too, sort of the difference between on-prem versus cloud, where we used to be worried about how much space we were taking up versus cloud. One thing that's interesting about Google, for instance, we use GCP, Google Cloud. I can't remember what P stands for. But anywho, their storage is free. You can put as much data on there as you want. What they charge you for is when you query it. So let's say I've got 300 gigabytes on there, and then I want to summarize by month to look at how many different customers we had. That SQL query might be intensive. That query itself might just cost me $5. So that's how much data storage is changing. Is that we went from like, we need to be so careful with all of the memory that we have on-prem, and we're not wasting any of it, and there's no replication, to now I don't care. They're just going to charge me by the query. So, and there's, what's that? It can get expensive if you're doing intensive stuff. Google also offers like machine learning things that live off that too. So let's say I train a model, while I'm training that model, they're going to charge me for all the queries that are going on in that. But then the model's done and it's good. Like I'm not paying. I've trained it. It's good to go. So it certainly can get pricey, but I've yet to work for a company that is truly utilizing big data. And big data, people say that a lot, big buzzword. I consider big data to be something that your local machine can't handle, where you need virtual machines or you need Apache Spark, Databricks. I had the, yeah. Oh yeah. That's actually a good point. At UNMC, they have a huge computer cluster thing that's where they send all their stuff. They have people essentially in line that send over your query and it does it and then they get it back and that's and yep.
She says that, yeah, like she did it from home
Mhm.
and get all these, I don't know.
VPN and stuff. Yep.
Yeah, because she says the computer's slow, so much shit.
Yep. That.
Retrieve, make article or not article, peer reviewed research.
Yep. So yeah, and that is a good example of where on-prem, in my opinion, is better, because if you're not necessarily just using that to store stuff on, you're using it because it's a fast machine that you have complete control over and you know your overheads, versus something when you do use cloud solutions. I've heard horror stories from every place that I've worked where an intern accidentally left something on for way too long. And it cost the company $20,000 in 1 week because they left it on too much. So there's plus and minuses to everything. But yeah, so data, we talked about data storage, data organization. You kind of get it from the name. Data quality management. That sort of gets back to some of the stuff I was talking about earlier, where it's like we want all of our numbers to be a specific type, like a float or an int, but not a string. So that's like a sort of quality management. Governance is crazy. I don't recommend getting into any governance conversations because you end up talking to people that don't know about data and they want to make sure it's just HIPAA is a big one with data governance. That was huge when I was at UNMC. I was actually there when they had the breach. And so that was somebody that just downloaded HIPAA stuff to their personal machine and somebody got a hold of it. That's essentially all that was. So yeah, data governance is huge, but very nuanced and very tough to make everyone happy. Because obviously data scientists, data engineers, they don't care. Just give me all the data and I want to do stuff, versus people that are in charge of that stuff are no, we need to be very careful. This is information that could be harmful, or maybe it's financial information that we don't want people seeing. So yeah, that's sort of governance. And analytics, again, that's why we're here. Data manipulation, obviously that's SQL, right? That's what I want to do. I want to select patient and age from patient table where age is greater than 60. That's the data manipulation I'm doing with SQL. But there's there's other sort of libraries that can do that too. Pandas is the one we'll be using in Python. Pandas is super handy. There are people that have pandas tattoos. They're just pandas nuts. I'm not one of them. Panda's really cool, but I'm not. If anything, I'm a Spark guy, but that's neither here nor there, I guess. Polars is the new sort of rival to Pandas. It's a lot quicker. It uses a language, I believe Rust is what it uses. I have a little blurb down here about there's the main data science languages, and then there's the data science languages that are think of it almost like command line. It's the stuff under the hood that's doing all the hard stuff that an engineer put together that lives and breathes that stuff. That's what Rust is. So yeah, and then there's dplyr, which is an R package that is very similar to pandas. Data table is sort of the polars to dplyr. It's a lot faster, but people love the dplyr syntax. And then, so I have written here that pandas and dplyr have SQL backends. That's something that we'll be messing with too, where if you don't want to write SQL, we can bring in a SQL data frame object within our notebook, and then you can use pandas to do your manipulation, and it'll automatically generate the SQL to do that, so you don't need to write the SQL. So I actually never learned SQL traditionally. I did everything through dplyr. dplyr did the translations, and then I would look at the translations to actually learn SQL, because my brain worked with dplyr, but then seeing the translation, I was like, oh, okay, now I understand exactly what's going on. And then obviously Apache Spark, which also has a SQL backend. It's more of it's different though. It's like they took, so newer cars, for instance. I'm going to draw another car analogy. So like my wife just got a hybrid, and one of the things with hybrids is they don't idle. Like idling is like a thing from the past, but people are so used to cars idling that like they're like, well, I guess we'll make it idle a little bit so you can feel like you're driving a normal car. So it's like this weird remnant that we don't necessarily need, but we're so used to. That's sort of what the Apache Spark backend is. Like Apache Spark is so fast, and it's like, use Scala to query all this Apache Spark. And people are like, no, we want to use SQL. And it's like, just learn the new stuff. And they're like, no, we know SQL. We want to use SQL. So that's why SQL is sort of universal with all this stuff. That's why it's super important. It's like the car idling. Like they got to put it on there because that's what everybody knows and is used to.
Do you think some of that has to do with also like how expensive internally the companies that, you know, are used to a certain software, stuff like that, then it also like, that also would be X amount of money that we don't project spending on for.
Oh, totally. For new learning and stuff like that. Totally. And like Apache Spark is so cool. The Spark SQL side of it is so cool that like they pride themselves on saying, like, let's say you're on an on-prem database and you're moving over to a Spark data lakehouse. They're like, copy your old SQL from your old on-prem stuff, paste it into Apache Spark, and it'll run perfect. And it's faster. So just exactly what you're saying, just the idea that we can take our old stuff and just put it into the new stuff and it works, that's the key right there. But it is, SQL's like 30, 40 years old. So it is sort of like, you just always have the trade-offs. You want to use the new stuff, but so many things are so cemented on the old stuff that you sort of have to sort of like pay it some homage, I suppose. So yeah, we're just talking about SQL right now. You guys have everyone's heard of SQL, I'm pretty sure. You guys had it. So yeah, nothing new there. I put in a data set. These are all the Nobel laureates, I believe. So I just selected everything where their broad field is engineering, and you can kind of go through and you know, that's SQL. We've got this data. And so, yeah, this is another example though of like, what is the granularity of this data? Each one, so this column 0, this is the number for each person, I believe. And we can look, oh yeah. So let me see if I can start this thing actually. This notebook is supposed to run, and it is not running. Whatever. I'll try and get it in the next class. But yeah, this is just another example of when I talk about data granularity. We could see that each one of these is a person that won different things in their different fields and whatnot. So yeah, SQL is boring to me. I always want to get onto the good stuff. So spreadsheets, this sort of, I mentioned this earlier too, spreadsheets are that tabular data, that 2D array or that data frame. When you look at Excel, that's what this is, a spreadsheet right here. And that's what a lot of non-technical people will use Excel like like surgically, like it's insane the things that they can do. And I'm like, take that and learn Python with that. Like, but everyone can do whatever they want. I'm not judging or anything. But it is very powerful. It is also sort of the bane of my existence because some people only live in that world. And so to get the sort of translation of what formulas are going on within this Excel doc that I want to replicate on a database, like those are the types of things that I do specifically with Excel. Microsoft Access is sort of like, it's almost like a SQL database for like Excel docs. I've seen Access databases that are gorgeous, that are clean, that are very easy to query. And I've seen ones where everything in there is something that somebody has manually input. And so what do we get when people put things in manually to a spreadsheet? We get mistakes, we get inconsistent columns, we get inconsistent names. So that's why I stay away from it. Airtable is like a cloud version of Excel that's really handy. Again, for non-technical people. Google Sheets I use to populate my resume. Every time I need to add something to it, I go into that, I put it in, and then I have a Python script that outputs a PDF and an HTML file. So Google Sheets is super cool. But again, it's just Excel online, basically. And so we'll work with some of this data so you can kind of see what it is. I uploaded a CSV to this. That's what we were querying. Now it's something that comma separated. Why can I not remember anything today? Anywho, that's something that you would open up in Excel. Yeah, so let's move on to modeling language. And then we're getting closer to Python, I promise. So yeah, these are sort of, and this changes a lot. These are the modeling languages that everyone uses right now. Python is obviously why we're here. That's what we want to learn. It's an object-oriented language. Very easy to read. That's why a lot of people like it. And it is versatile. You can also do a lot of it distributed as well. So that allows scalability. So let's say you build a model in Python and suddenly they're like, we want to send massive amounts of data to that constantly and then get stuff back. Python can handle stuff like that. R is an academic language, in my opinion. I've worked a lot with R while I was doing stuff at the Med Center. R is great for graphics as well, dashboard building, stuff like that. When I was at Methodist, that's pretty much, they used R for pretty much everything. Scala is cool, but hard to code in, but I put it in here because that's sort of, Scala allows the Java virtual machines to do their thing within Apache Spark. Again, that allows us things to move very fast when you're programming in that area. Julia is a new one, and it's cool. I've used it a little bit. I'm not completely sold on it yet. I think there's still some things that need to get worked out. But it's fun. I have a feeling if I'm teaching this class in like 5 or 10 years, Julia will move up that list. I think it gets better every year. But yeah, I haven't messed with it too much. And then, so these are the other languages. These are sort of the behind the scenes languages that are doing stuff. Obviously Java does a lot with some of the Scala implementations. Rust, we talked about, is the back end of Polars, which is a good data manipulation library. And then C is like, don't ever do C. Just kidding. C is really cool, but C is like you're gonna code a lot. There's some of the guys write C cloud functions at Buildertrend, and I look at them and I have no idea what they're doing. But it's cool. It allows, again, when it's the back end for packages that we're using in Python, who cares? Somebody already built that for us. We just have a package that goes really fast thanks to C. So we got to give it up for these packages, but again, we don't necessarily need to dabble in them too much. Visualization, you guys did with Tableau. Tableau is wonderful, again, for stakeholders to sort of really digest this stuff, especially when you have a good story to tell with data. I'm sure Charlie touched upon that. Like that's what it's all about when it comes to visualization is what are we trying to convey, but also what are we making actionable to our stakeholders, to the people that are using this stuff? How are we allowing them to make better decisions with the stuff we make? So I wrote a little bit of Python here to just show some very simple visualizations. These are the type of things that you'd maybe see in like a write-up, a publication or stuff like that. We'll get into some of the cooler stuff. Plotly is a interactive one that is a lot of fun. We're definitely going to play with that. Bokeh is another one we might actually see during this class. Actually, we're kind of blazing through this. Yeah, so we'll touch on. I'll talk about that stuff when I can actually show it to you because it's actually fun and cool. And so yeah, now we're going to talk a little bit about the enterprise solutions that I've sort of been alluding to. I talked about Databricks. Again, that's all cloud. None of that's happening on my machine. I'm interacting with it through the browser. I'm writing notebooks in the browser. It's going to a virtual machine that has 255 gigabytes of RAM and it's super fast. And then when I'm not using it, it powers down. Those are the sort of enterprise solutions. Similar, again, like the one at UNMC. We got this huge machine. We're going to send stuff to that. It's going to come back. If you don't have the luxury of having something like that on-prem, we're going to use some sort of an enterprise cloud solution. And that comes down to scalability. Your laptop can't do everything. Like you're going to, especially when you're working with terabytes or petabytes of data, we need to bump it up. And so that's what scalability is. And then collaboration. We talked about version control. If we're all on the same Dataiku or Databricks thing, and we're working on different branches, we're putting all the pieces together to make this model. That's what these enterprise solutions also allow. And then ease of use. As I think you guys kind of dealt with the SQL stuff, there were problems getting some of the stuff installed on the computers. Is that right? Mm-hmm. So when you have virtual machines, enterprise solutions, all that stuff is taken care of. You can literally tell exactly what version of Python, what version of the package you want. Every time these things fire up, it's the exact same environment, so nothing ever changes. You don't accidentally update something and then your Python installation breaks and then you have to, So that's obviously a huge part, and that comes down to reproducibility as well. When you make something and it works, if you turn your computer on and then turn it off and then turn it back on and suddenly it doesn't work, it's probably because you had something in your environment that you didn't know about and now you have to go through. So reproducibility is obviously huge. And then customer support. I'm the type of guy that just wants to read the documentation and figure out himself, but customer support is big for people that are maybe a little bit more non-technical that are working on stuff. Or if I need to install a different version of something and I have to go through the command line in Linux, maybe I'll call customer support and make them do it because I don't want to deal with that stuff. And then integration. Dataiku has really good integration with some model registries, similar with Databricks, which then allow for deployment to APIs. So it's sort of like, what's the sort of life cycle of whatever it is that you're building? And that's the sort of integration side to it. I've talked about some of these. Dataiku obviously is huge. I believe we'll be using Dataiku in like the next Python class. And we'll actually have a decent amount of power behind it. It'll be more powerful than the Anaconda Cloud stuff that we are going to be doing here shortly. Databricks is sort of my bread and butter. Again, that's all built on Apache Spark. And that just allows stuff to run extremely fast. And it is fun. Alteryx is more of like a non-technical type of data science solution. I've not used it. I know there's a place in town. I can't think of what they're called. I know it's used around town. So you might run into it depending upon your, professional journey. SAS is I have only heard horror stories about it. I personally have never used it, but I know, again, similar to Excel, people that use SAS are very, very good at what they do if that's what they're using. There's a fair amount of integration with SAS, like objects that you can take into, I believe there's like a Python connector. I know there's an R connector. Yeah, and so then Microsoft Azure is kind of like Microsoft's version of like Databricks or Dataiku or something like that. I haven't used it too much. I like more of the open source stuff, which that's what Databricks is. And then, yeah, we can ask ChatGPT what its favorite platform is. All right, so now we're going to get everyone going in Anaconda Cloud. And once everyone's good, we'll probably take another break, if that's all right. So we're going to click this link here. And then it's going to ask you guys to sign up. It's free. I think you can click the don't send me newsletter thing if you want. That's what I do. I don't need to know anything. So I would say, has everybody been able to log into that?
Me right now.
Cool. When you do get logged in, you should see a screen like mine.
It's a matter of big academic or professional.
Do academic, I believe. Is it asking for like an academic email?
No, necessarily.
Okay, good. I still have my UNO email address. So when I did the Deep Note stuff, they were like, if you have an academic email address, you get a bunch of stuff for free. And I was like, sweet, I'm doing that. So yeah, folks online too, when you get in there, give me a holler on your mic or just let me know in Slack or in DMs too. If anybody's having trouble too, let me know. I can try and troubleshoot with you.
I may have missed it. What do we put down for position?
What's that?
What do we put down for position?
You can put whatever you want.
Okay.
You could put academic, you could put student.
Okay.
Yeah. Oh, yeah. Okay. Academic.
Then
Yep.
afterwards, it said, like, what is your-
Oh, I'm sorry. I meant to say, what do I put for company? Sorry.
You could put ODSA if you want.
ODSA? Okay.
Yeah, I think that's what I put on mine. Let me look. Yeah. And none of this stuff, this is more for them to like see who's using their platform. We're literally generating data for them right now that they're going to utilize to figure out who's using their stuff. You're always you're always leaving a data footprint. And then Nate told me to take roll. Who are we missing? We're just Ryan. Yeah, Ted's in the chat. James is in the chat. Charity's in the chat. Michelle's in there. Yeah. So just Ryan. Okay. Is everybody good? people online, I'm assuming no news is good news. So we're
I'm
going to
still having problems. It's not. It's just not allowing me to register for free. Do I have to put in like a non-Gmail?
pretty sure I used my Gmail account. Yeah, just make sure that you're putting student in. Yeah.
I clicked academic. I'll try it a different one. I'm not sure what's going on. I'm gonna try a different browser.
What browser were you using?
Chrome.
Well, I feel like that should work.
Yeah.
Interesting. Ted, I wish you could share your screen. I wonder. Let me see if I can do that.
I can.
Yeah, if you want to, feel free. I can stop sharing, and or if you put your screen as like a thing, I think I can look at it. Let's try this.
So you should see it now.
Yep. So then register. And then I am an academic. And then I agree. And it is not. That's bizarre. It's just not even.
It is very.
And that's Chrome. Oh, no, I'm sorry that you have to use Edge.
I know.
You guys didn't have that problem? Everything else went through? Okay.
So needed.
I'll put it up here so you guys can all see.
Yeah, see, one is it's not here either.
Do your path?
You just have to click on professional and see if it changes.
Yeah, hit professional and just see what happens.
And then,
And then back to academic.
yeah.
This is the craziest thing I've ever seen.
Oh no, what have I done? Why is it doing that?
Not to worry. Let's not hold everyone else up. Go ahead and keep going. I'll reboot after class and just catch up.
Okay. And yeah, feel free to hit me up on Slack too. A lot of this stuff, we're just going to be running the notebooks that are in there and talking about them. We're not going to be doing too much actual coding. I mean, unless you guys really want to. So yeah, let me go back to.
Thanks.
This one, share. Woo! Woo! Okay. Man, I was convinced that no one would have any problems. I told Nate, I was like, we're doing this. Everyone's going to be able to sign up. And of course, Ted, real quick, is there any way that you have already signed up for Anaconda?
Well, that's something I was checking as well. But I could see absolutely no reason why I would have.
I'm going to log out on mine and do sign up. Oh, sign up. Put my stuff in. Let's see if I can recreate this. Use strong password, sure.
So it wouldn't even let me click the email me.
Dude, that is so bizarre. Yeah, there could be like a ad block or like pop-up thing that's on your browser that's doing it. I know I had issues with that on Google Cloud Shell when I was sort of developing some of this curriculum. Man, this bums me out. It's on Windows.
Don't let it hold us up.
Sure. Well, we're at a good time for a break. Ted, if you're cool, I would love to try to troubleshoot this with you, man. Do you want to maybe try the Brave browser? I don't know why Chrome wouldn't work. I'm going to try Chrome on mine real quick.
Chrome and Edge, either of them worked.
Ooh, it's giving me fun recipe ideas. Okay. Anaconda Cloud. Register. Nate. I'll sign Nate up for it. Let's do a different email address. My builder trend email address. Why not? Okay. A strong password. Yes. Oh man. I'll do this later. Now. Okay, password is just going to be its own thing. Fair. Come on. Pandemic. Okay, now you recreated it. It's not working for me in Chrome either.
We have to click over.
Ah, no. Oh man, this is heartbreaking. Yeah, Ted, you want to try that? Try like an incognito tab. So Chrome, new incognito window, and maybe try it in there.
Giving it a shot.
That is very, see, that's problem solving. that is problem solving. Ted, if this doesn't work, we're going to make you an account. We will get this to work. Shout out to, is it Anna or Anna?
I answered both. But
Okay.
I think the way I pronounce it is Anna.
Yeah, that's what I was going to say. But well, let's do that. Ted, do you want to message me your email, and I'm going to put it in here, and then I'm going to put in a password that I will then send to you, and then you can change it if you're comfortable with that.
Yeah, of course.
Oh, he's not doing this session?
I think he struggled a lot with the remote piece last class.
Oh, yeah. That's
It's tough.
that's the main reason that I agreed to do this, is that at least most of it was in person. It just is easier.
I think there was something with this though, with this like computer, yeah, it was like specific to them, you couldn't get certain things to like run.
Yeah, so like, I think,
Hey, James, are you having problems with yours?
Oh, there it is.
You should still try to do it. You should still come in.
Okay. There we go. Can I see this password? There we go. Okay. Ted, I'm just going to fill this out for you real quick. Company.
And he just, I think he said just a session.
Oh, he'll be the next one?
He just said this session, so I don't know if
If that means class or,
I don't know, to me, it sounds like the class. That's
Yeah.
But I said, watch tonight's thing and then decide. We'll see on Wednesday. Don't give it an option. Yeah.
Everyone said they'll see you on the.
education company side, no emails.
Ryan, you better come back.
Okay. Ted, your email is good. I just put the password in the DM. Feel free to change that. And I will sign out so you can sign in. And yeah, well, once you're good, we can chill for a little bit longer if people got to stand up, go to the bathroom, water, whatever. When you guys leave, I'm going to ride my bike around this room. No, I'm just kidding. Nice. I mean, if I have to, yeah, I've got like proper gear to do that stuff. Yeah.
I don't think anything stops Doctor at this point.
It's weird stuff, me, but I'm not a biker.
It-
That's the same way. He like wears like he looks funny when he wears the outfit. But
Does he wear like the bib, or does he just do
he wears
spandex?
things like you know those like back in the day those hats that would strap out
Yeah.
like those tracksuits.
Yeah.
So there's one like that that's for like the rain.
Oh, yeah. Okay, I got you.
So
Yeah.
he puts those at, and then he has like a rain coat. I don't know. It's actually a coat to like that.
Yes.
So yeah, he does have certain. It's kind of expensive because Javi has kind of expensive.
I mean, that's the thing is like I always like tout like I don't buy gas. I don't own a car, even though I paid for one for my wife. It's like, well, you got upkeep on the bike. That bike back there is a single speed, so I can do most of the maintenance. It's like when you get into geared bikes, like you sort of age each cog differently depending upon how long you ride on it, and then shifting gets weird, and I need simplicity. I need just one gear, and my legs can do the rest. I'm gonna take this down because it didn't work.
So when it's snowing and cold, what happens?
Cold is fine.
I guess it's snow wintertime.
Wintertime is, I don't, because I mean, I don't have a need for it. My job is remote. Yeah. You knew it was there someplace.
He just got to get around.
He just got what?
A winter one.
Oh, nice.
He has, I'll show you, he has a fancy schmancy bike.
Really?
Costly and kind of like, I guess, he drives every day, so I guess he can.
Your husband's name's not Joe, is it?
No.
Okay.
He's an Andrew.
Okay. I know a Joe who fits this description.
Oh, really?
Yeah.
You sound like a Joe. Just like
Do you ever get tired?
I mean, yeah, if I'm riding like 100 miles.
what's like your average bike?
I mean, so I literally anymore so I just bike because I'm bored. So like I work from home. I'll like over lunch, I'll go ride 20 miles over into Iowa or 30 miles into Iowa or something. Oh, that's pretty.
Yeah.
Fenders and everything.
Yeah, he's a little schmancy guy.
I had fenders on that bike for a while, but they just got rickety and they were heavy. And now try to keep it simple.
Like copper on the, and then you got me one, so you think that I could write this much.
My wife is the same way. She has my old Bianchi in the basement and she just looks at it. And I was like, honey, our daughter is at the point where I can pull her, which means I have to slow down because that's what she always gets mad at me about. She's like, you're going too fast. And I'm like, I got 2 speeds, go and don't go.
I had an extender because I'm so short, that like, when I get up, I like have to like get on the curb and like hop.
Yeah.
And my husband found a way that he can get, so I basically have hydraulics on my bike. So like when I get up, it goes up, I can click the stand, it goes up. And then when I'm on, I can go down. And then
Wow.
my husband figured like nonstop, I'm telling him, he was like, oh, you're gonna bite, I'm gonna get this. And I have broken plate, it's actually pretty nice.
That's honestly sick. Yeah, that's really cool.
Yeah. We're supposed to go Sunday, but then it rained so badly,
Yeah.
you know, all throughout the weekend. So- Yeah.
Well, windy. That's the one thing. I always know about the wind.
Yeah.
All right, we'll go another 5 minutes. Ted is in, everyone. Everybody else, remote is good, I'm assuming. If you're not good, hit me, DM, Slack. I'll give you Nate Watson's phone number. You can just send it to him.
He's actually going to be up here with me tomorrow in Chicago.
Really? Nate is?
Yeah.
Nice.
Yeah. It'll be cool.
All right, I know I shouldn't, but I'm getting more coffee. Okay, I think we'll just get going. I think that was enough time. All right, so close, 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 close. Oh, my banner is still on. Classic. Okay. All right, so everybody should be on the Anaconda Nucleus or Anaconda Cloud. I don't know. They have a bunch of different names for it. This is an ultra cool website with a massive amount of free tutorials. A bulk of our stuff is going to be going through this. There's massive amounts of documentation in these. We're not going to get very technical. We're going to get more, try and get to the things that you want to know how to do. Less about why, I think, just because, again, back to the car thing, when cars were first invented, you need drivers to do them, and they knew how to do everything with them, and now they're easier to use, and you don't need to do that. Data science is sort of going down that route, too, where it's like, back in the day, it's like, you need to go to school for statistics, and now it's like, well, no, I can just download this library and I know enough about statistics to know when things are statistically significant. So I don't need to spend all that money and all that time. And so that's sort of what we're going to be doing here. We can get technical if we want, but largely it's going to be about doing the things that you guys want to know how to do. So we're going to hit this little notebooks tab up here. And I believe some people were already there. You should see the nice little fun spinny guys. I got tons of stuff open up because I've been messing with this for a minute. But let me close. Oh, closed the wrong thing. Actually, I should do this with my Buildertrend account, but whatever. Okay, you're gonna close? Not gonna close? Did it freeze? Okay. So this is probably what everyone is seeing. It's this little thing. So is this what everybody's seeing on their screen? Yeah, it might take just a second. Still spinning? You got it? Cool. Again, people online, I'm assuming no news is good news, so I'm going to keep on plugging away. So yeah, this is just this little like regular notebook thing. There is massive amounts of information in this. If we look to the side, we see the sample notebooks. Going through all these is really cool. We are going to start in the bottom one, the Python programming course. I think we're going to do, so you can, if you want to, this first one is going to be like an actual web page. And this, similar to sort of how my write-up was, this is going to show you like from the ground level how all of this stuff works. I think this is a little bit boring. I'd rather kind of show you how this stuff works. But if you ever need to reference this stuff, it's all here. It's all super handy. One of the things just about learning programming in general is sort of wrapping your brain around the syntax. And when things don't work the way that you want, sometimes you have to dig into the documentation a little bit to try and understand why that is. So all of this stuff is here if you need it. But we're going to go back to Python course and go to basics and go to functions. So again, you can read this, but functions are sort of like putting together like a math problem, or like putting together like for this one doesn't actually do anything. It's pseudocode. But for instance, if you had something like you wanted to add two numbers, you wanted to make a function to add two numbers. Obviously, you could just do 2 + 2. But if you wanted to make a function, you would define it as this sort of little def guy. You would name the function, and then you would have argument 1 and 2. So in this case, if we named this sum and we had number 1, number 2, we would then return adding those together. So that's a very simple context of how you can make functions, but these things can get extremely detailed. You can make these functions do whatever you want. If you think about algorithms in social media, those are largely just huge functions that are saying if they like this, give them this. If they like that, give them this. It's a big, huge algorithm within a function. That's largely, this is just a simplistic version of that. You're making something and you want it to do stuff and give you what you want out of it. So yeah. Where's the good stuff? Common error, blah, blah, blah. Yeah, so does this one run? Oh, yeah, this is all, I thought these ran. But yeah, well, let's pick this one apart real quick. We've defined a function called getNumberWord, and it's a number. So it takes a numerical value and returns the word corresponding with that number. So this is obviously a very, if you coded this whole thing out, it would be huge, but the syntax is very simple. We're going to use the if number, this is the number we're passing into our function. If it equals 1, and with the colon, we're telling it the next thing to do, so we're going to tab over, return 1. And then else if, so the if starts the statement, the algorithm, if that makes sense, and then we're just bumping down. We're going down. All right, if it's not 1, it's going to be 2. If it's not 2, and it's just going to go forever. So this is it illustrates sort of what you can do with functions, and it's a lot. This is obviously you would never really want to code this. Trying to think, I would probably, if I made this, I would probably find a package that has all of the numbers written out and just have it return that number. So yeah, let's talk about packages. Where's packages? All right, we will talk about packages. So if we go back to sample notebooks, hit that up at the top. Now we're going to go to Intro to Data Science. And we're going to go to this first one that says, Nate says NumPy, I say NumPy, but that is a package. Right. So NumPy is a pretty powerful package. If we look at some of the stuff in a nutshell, a powerful Python extension for n-dimensional arrays. When they say n-dimensional arrays, I know that sounds terrifying, but a two-dimensional array is our spreadsheet, is our data frame. In this class, we're never going to work with any higher dimension than a two-dimensional. So again, think of it as just Excel, grid, data frame. That's what we're working with. That's what NumPy is going to work with too. And then here, what's this built on? It's built on C and C++ and Fortran code. So again, these are the disgusting languages that we don't want to deal with, that somebody way smarter wrote the backend for, and now we have this very powerful package to do stuff for us. So yeah, if we want to use things in a notebook, we use this import NumPy, our package that we want, as, and then NP. And so now we can use that. And then if we want to run this, just so everybody knows, I do Shift Enter, and it'll run that Python chunk. And so here, if we do NP, so again, NP is that's what we've imported our NumPy as. So if we hit NP, and you can do this within the script too, feel free to mess around with these. NP, and we do a dot and then tab, we should see all the different things that we've imported. So all of these are different, essentially functions that we can use on pretty much any number. Obviously, if you don't know what you're doing, you're like, what am I going to do with all these? But let's do something simple. Everyone's familiar with absolute value. Absolute value means if you have a negative number, the absolute value, you drop the negative. So if I have absolute value of -1, I'm going to return 1. It did that. It's a nice package that is now going to do exactly what I tell it to if I want. So if I have -7, it's positive. Hooray! And again, we imported this package. We said we want NumPy, and we're going to say we want as NP. But let's find out what happens if we don't say we want to put it in as like a particular thing. Think of like aliasing that you guys did in SQL. Are you guys familiar with that? Is that something that you guys talked about? So like when you're doing something in SQL, you're going to do select date as, and then you say date today, like you rename it.
Yes.
Or on left joins, when you're saying left join something as, and you put that, so you're aliasing it. You're doing the same thing here, essentially. So if we import NumPy without aliasing it, now we have to call the whole thing. We have to type out NumPy. Now, here's all the stuff that we had, right? There's our absolute value of -1. 1, hooray! So that is packages. And so packages are, at a very low level, packages are a collection of all those functions that we were looking at. Like if I wanted to, I could write this from scratch. I could write a function that takes any integer, any number, and gives me the absolute value. So if I give it a negative number, it's going to drop that negative and give it to me. But we have packages to do all this for us, and they're the best. Nate sort of talked about how when you're putting together some sort of a machine learning algorithm, even if you want to write it from scratch, any more so, you can just go to Wikipedia and copy down the core code and put it in there and run it. And I was like, Nate, nobody does that. People just import the packages, man. Like, I don't know why you're going to Wikipedia for this stuff, but hey, you got to do what you got to do. So yeah, now we know how to import. And in this case, we're using NumPy. I'm going to go ahead and import it as NP again. I'm going to run that script. Let's see what happens if I mess something up. Let's say I fat finger something and I say numby. I'm going to run that. Ooh, we get a nice error that tells us what's going on. There is no module named numby. So that is what happens when you get an error like that. When you just see this run, then you know it's good. Similarly, so when we talk about object-oriented coding, I can make an object in this right now. So right now I'm just saying, NumPy, give me the absolute value of 1. But what I could do is I could say x equals that. So now what's going to happen is we're no longer just returning that value. We are assigning that value to an object in this case. So now we have x. It's like, oh, what's x? Now I can say print x. There we go. There's my 1. So this is handy, again, when you are making a function that's doing multiple things. Like absolute value is just one thing. Maybe we want to then sum all of, like, what if we put a list in here? We have -1, negative 12. Let's go. -4, 9, 10. And so we're going to assign that to x, and then we're going to print x, and we get all of our stuff out. So assigning these things to variables, especially within functions, means that you can think of it as like, do one line, we got that, and now I'm operating on the next line, and everything is just going line by line right down, doing all the things that you're wanting to do. In this case, I'm just showing you that we're doing that with absolute value. But I'm trying to think of let's keep going here. I think there's some other sort of functions we can kind of play with to sort of understand what's going on. Okay, so yeah, n-dimensional arrays are homogeneous. What does that mean? We won't get into it. Yeah, so here we go. So there are different types of, in this case, I put this would be a list if you use the brackets. So I put a list in there, but you can also turn that into an array. And that's just a sort of another data type within Python. And that's something that you can specifically call. Again, we're calling that from our NP operator. So we've got v, so let's print v so we can see what that looks like. So there we go. We have this nice array. But let's compare that. Let's see what that looks like. Let's take our guy up here. And let's say this is x. And then let's print x. And let's compare these two. Let's see if they're the same. What do we notice? It is very subtle.
The commas.
Exactly. Yep. So that's the difference between, and I mean, it's subtle, but that is essentially the difference between a classic list that you're defining and then arrays. Arrays are like, that's what NumPy is bringing to the game in this case, is we have a new data type called an array, and we can use that to send through lists. We can make these arrays bigger to like a 2D array, again, is that tabular form, is that sort of grid Excel data frame. And this is like sort of the foundation of working with data within Python. I would sort of say that we're looking at the very bottom, at the tiniest piece of something that is much bigger. Is that the okay? But that's what NumPy is sort of bringing to the game here, is these new data types. Arrays are typically, I think they're faster than lists. Here we have two lists. We have 1, 2, and 3, 4. We're turning them into an array. Does anybody think they know what's going to happen when we execute this one? So again, this is similar to what we had up here. We have a list defined by the brackets, just like we had up here. But we have a comma, and then we have another list, and we're saying turn this into an array.
2 lines.
Exactly. We're going to get 2 lines, so this gets close to that sort of tabular form that I keep talking about. This is like if I exported this as a CSV, you would open it in Excel and you would just see 1, 2, 3, 4, and those in that order within the So then we're looking at types. Yeah, so actually, let's go back up here. So if you put type around the object that you define, you'll get its type. Imagine that. So again, here we've defined our V as that array 1, 2, 3, 4. We have X as those negative numbers that I was using to show how the operators within NumPy work. We noted that the array didn't have commas and the list did have commas. So if we run this again and run type, we get list for both. Interesting. I wonder why this one is saying. Oh, I know why. Because it's doing one at a time. So that's why this guy has the print statement here. So if I go, I spell print properly. Here we go. So we see our V is that NumPy array, and we see that our lists, the more traditional one with the commas, is showing up as an actual list. And so this just illustrates the different types of data and the different ways to put it within Python. Again, I know this is kind of like, this is very small in terms of like the big picture of how to use this stuff, but it's important to understand the different types of data that you're working with for a multitude of reasons. If we are feeding data into some sort of a model to get predictions out, it might need to be an array. So you might need to load that in via SQL or something like that, and then call that an array to feed it into the model. So that's sort of why we're going through some of this stuff. Similarly, so we ran this, we saw that we got our sort of 2D array out of this. Here we see that they are arrays. Now we get into shape. So when we talk about shape, we're talking about this array up here. Like, what shape is that? It's a square, right? There's 2 across, there's 2 down. So let's see. There we go. We see the shape of V, which we defined up here, was just an array. It's just 4, and that's it. And then we look at our M, which we said we have that comma here, so we're saying take these 2, comma, we're moving the other ones down, and now we've got a 2 by 2 square of our numbers. And so yeah, this is again the sort of intuition to understanding tabular data, understanding that sort of like grid-like stuff, and understanding like what if I wrote, let's do another one. I wonder if you can do, see if I can mix. I think this will break. Oh, I did it. So let me. Nope. I want a whiteboard. Okay, so I just added 2 versions of my name to the bottom one because I thought that would be a good idea. So again, we see our 2D array right here. And then I've added a string to this. And so what we note here is that by doing that, I have then now converted everything else in that array to strings. Do you guys see the commas around here? So that denotes that this is now a string. It is no longer a number. So if I were to try to reference these two with a function and say, add those two together, it's going to be like, no way, dude, those are letters. I can't add those together. So it's important to understand your column types, what you can and can't do with them. Again, you can't add, unless A is defined. If A is just a string, that's like, you can't add A and B if like they're like letters on paper, like you just, yeah, that's essentially what's going on here. So yeah, let's see what else it does with this. So it's still an array. Let's look at our shape now. So what would happen here? We now have 2 rows, but 3 columns, just like we see here. 2 rows, 3 columns. And then I think if we just write this, does it get mad? Nope, does the same thing. So yeah, there are print statements you can use. Print is, to me, more of something that you give yourself. So if I have a function that is, let's just say I have a function that's using that absolute value. After that function is complete, if there are no errors, I might put a print statement that says everything ran. Like that's sort of what print is for. It's not necessarily for like returning values within a here. Okay. Let's do one here. So let's define abs as x, where odds x, and I type, there we go, equals np I'm finding the same thing. Let's write it. This is my function. Okay. So I've just defined a function that I want. I'm using another function, but it's just to illustrate what's going on. And so I run it. And so now I've got this function. And so if I call it, say Tom abs -1. So what's going to happen when I run this? Does anybody want to take a guess? You're right. I mean, it's not going to error, but it didn't return anything. Within the function, I've defined a variable, but I didn't do anything with it. So it's just like, cool, we'll call this positive x, and then we're taking off for the day. We're not going to return that to you. So if I put return positive x, we run that again. Woo! So that's another thing to think about when you're putting together functions. Return is going to give you something that you can actually use. This is giving me a numeric thing. If I put more than one thing in here, again, let's put in, what did we define? X. There we go. This is our X that we had up here. Remember, we had -12, -4, 9, 10. Put it through this, it returns it in a beautiful array. And again, remember our forms were in an array, so this is something that I can operate on later. What if we put print? We just get back our list. So this is something that you not as usable. You want to use that return to get stuff back. Okay, I'm going to pause for a minute. Where are brains at right now? What doesn't make sense? It's too much? I'm trying not to hurt people's brains too much. That's my favorite class. What other questions? Is it like, are you wondering about context, or is it?
So would it always be like this where, I don't want to say like cheat sheet, but kind of, you have what you have in front, like, print, parentheses, shape of, would it always be like that?
Right. Yeah. So that's a really.
Within the man, the fence, what, like, is that fixed, right? Is that what you're saying?
No, I mean like.
Cause like print, that's always gonna be on the, there, but like shape of the, that's what you're making, that's your defining,
Right.
so.
No, but like for example, you're not gonna get like a clean sheet of paper in the card and we'll make up something. Or you're gonna have like, I guess, a problem and then you know what the problem is to resolve it.
To an extent. So let me.
You're trying to solve a problem, so like you might already have a problem, but on a paper, I would say, you're trying to find how do you.
So I guess you make your own problem.
No,
Yes.
The problem usually there, isn't it? When you say-
It depends. In this case, right now, we're sort of going through a worksheet. But to your point, what if I had a blank piece of paper? Here it is. This is just a brand new untitled notebook. The first thing I typically do is I import. In this case, NumPy is the one we're working for. Import NumPy as NP. That's in. Now I can use that NP array. I can do, R does that. I don't know if this does that. Nope, it gets mad. So I get what you're getting at. You're sort of saying, yeah, you can do all these little teeny things, but like, how do you make a bunch of little teeny things do something cooler than these little teeny things? And that is, we'll get to that, but it's important to understand some of the basics like this, because when things break and you don't know why, and it's because it's not in an array type, that's why we want to go back and understand this stuff. But I think you're also talking about syntax, and syntax is like, how do you know to use those parentheses? How do you know to use those brackets? How do you know when it's a string versus a number and stuff like that? That's all very good. That's all important stuff to know. I think, sure. Let me think for a minute. So if we back up for a minute and kind of go back to your point about what are you doing? Like what is this accomplishing? That is ultimately the first question that you want to ask yourself. When we go back to what we learned in SQL, what were we trying to do there? We are trying to query data. We know there's data in this database, and it might be weird, but I'm going to write this query to pull this data out. And now I've got it, and it's very pretty, and it's good to go. And so then we go to visualization and say, oh, I've got this pretty data. Now I'm going to make it tell a story. Like if we go back to the patients, I'm going to say older people tend to be more old. I don't know. You're going to answer some sort of question with that data. And then Python is sort of, I guess it is sort of driving manual a little bit. It is sort of putting together the building blocks to make these bigger things. And so that's a good point. I think next class I will bring bigger use cases. So we're not looking so small. Is that sort of maybe what you're struggling with a little bit, is like we're looking at these little tiny things doing like little things? Does that make sense? And I'm sorry, I'm not trying to put you on the spot whatsoever. I'm just trying to make sure that this is helpful for you. Oh no. Somebody was just live online. Does anybody want to chime in with anything? Have I confused all of you as well?
No, I was going to say what you're suggesting, I think makes sense to me as well. Showing a bit of a bigger, broader picture of what we're intending to do
Sure.
and then building up to it. So
Gotcha.
I think that would help me a little bit, but like grasping the functionality of it, those, things are definitely got.
Gotcha. Cool. I think we'll kind of jump ahead a little bit to sort of talk about sort of what you're saying, like, let's have a problem and let's see how to solve it. So let's see if this stuff is in here. So this one could be good. All right, let's see if this works. I don't think I've run this one. Okay, so this is a classic data set. This is everyone that was on the Titanic. This is like this is everything that is in this data set. Is we have P class, which is the passenger class, whether they were in first class, second class, or third class. We have survival. Did they make it? Did they go down with the ship? Is it Jack? Who knows? Then we have name, sex, age, siblings. So we have a fair amount of data with where they were. P class is a proxy, socioeconomic status. So essentially, first class people were upper class, middle class, lower class, yada, yada. Age in years is fractional age. So this is giving us sort of a write-up about this data set. And boy, oh geez, there's a lot. Cool. So remember how we imported NumPy initially? We're gonna put in pandas for this one. Pandas sort of builds on NumPy, but it's more of that data frame, like the tabular stuff. And then here the OS is going to actually get our data for us, and it's gonna download it as a CSV. So we can run these by themselves if you want to kind of see how they work. Let's do plus. So if I just run this without assigning it. So here it is going, on our virtual machine, it is going to home, the folder. It's going to this weird big long string that's going to be different for everyone because this is a virtual machine. It's going into sample notebook, and it's finding this Titanic CSV. And it's loading it into as data. So we'll trash this guy. And so now we have this. This is what our data looks like. And so to go back to what I kind of was talking about with patients, in this case, we have actual people that were on the Titanic. And this is everything about them. The fare, the cabin. Can't remember what body means. I don't think it's pounds because that is 300. I don't know, who knows? And then you have their destination and whatnot. So we've used the pandas operator to read this in, and so we now have a pandas data frame. And again, just like we had with NumPy, if we do a dot after that data frame, we should get a bunch of stuff we can do to it. So for instance, age was one of the columns. We can just print that column. What else did we have? We had P class. Cool. So we got all that. What other operators do we have in here? We have tail. Does anybody want to guess what tail does? Tail is at the end of something. Yeah, you. So if I want to, this just gives me a little snippet of the data. Like, let's just take a look at the last 10. There we go. This is the last 10 on there. These are all third class people. Let's see. Did they survive? A 15-year-old female survived. Pretty much everyone from third class, though, went down with the ship. It's bummer stuff. But then similarly, the opposite of tail is heads. Here we go. So this is the top of our data set, the way that it's ordered. Here we have first class. We have a lot survived, but we have people that did not either. And so remember when we used shape to try and figure out that 2x2 NumPy thing that we made? Let's do the same thing here. So this is saying we have 1,309 rows, and then we have 14 columns. And again, those columns are P-class, survived, name. So this is what we know about this data. And then values.
That's how it's.
Yep. Yep. So we can see these are all the different things, all the different columns within there. And then describe, this is going to give us like a quick analysis of our numeric, the numerics values columns within there. So we have, if people are familiar with a histogram, we can kind of see how that looks out. We can see the mean, the average. So this is kind of interesting. So of everybody in there, the average survival rate is 38%. That means out of 1,309, 38% of them were ones. The rest all didn't make it. So this gets closer to some of the things that you guys were talking about in terms of like, yeah, I can give them this data and they can look at it, but like, give me something useful. What's the percentage of people that survived? Boom, we got it right there. That's a piece of information that you could give to somebody. Albeit this is, bummer data. So we can see the average age was 29. Average fare was low, yeah. We can look at data types. Yeah, so here, this gets into some of the stuff that we were talking about earlier in terms of like strings. In this case, strings are objects. int64 is going to be an integer, which is a number. Right. And then float is going to be, means that there's going to be a big decimal in there. Floats can be big too. Some of this stuff, I wouldn't necessarily worry about too much in terms of like the different types versus float versus int. It can make a difference depending upon if you're feeding it into some machine learning algorithm. But for the most part, this just gives you an idea of what we're looking at. Okay. Better or worse? Better? Okay. Thank you. And like, this is, again, when this stuff is like, when it sounds like calculus, tell me. I adore calculus and I adore Python, but it's at a different level, obviously, because I do it all the time.
So do we have to memorize the data that types with little phrases or?
It depends upon what you're trying to do, right? Like, if you get a new data set and you're trying to understand what's in it, like, yeah, you can print the heads and the tails and you can look at this stuff, but like, what if you miss that fare that looks like a number here is actually an object or a string? If you plan on doing any sort of analysis on that, it's going to break. So this stuff is largely just for you to just check out the data, just to understand it better. Like, I know that sounds weird, but it's people kind of refer to it as data literacy in terms of like understanding the granularity, which I talk about a lot, which in this case, the granularity is every row is a person. I could summarize this differently and do a count and see how many people are male and how many people are female. That would change the granularity, right? Then we're just looking at male, how many people, just looking at female, how many people. I've changed the granularity just to 2 people. And so this is all, again, just for exploring the data and understanding what's there so you can find things to get insight from.
There's no right or wrong answer.
Bingo. And I know that sucks. I know it's, well,
There's no right or-
that's true. I'm just, for some people, they want, it needs to be this or it needs to be that. In this case, especially, this is called what I would call EDA, which is exploratory data analysis. This is us just like getting to know the data and getting to understand like what can we learn from it? Like what is are any of the data, is any of the data missing? So if we look here, we have a count. So this is doing exactly what I just said. It's counting in P class, how many complete observations were there? There were 1,309, which we know is all the rows. That means there is no data missing from here. But if we look down here, age, we're missing data. So we now know something about this data. If we want to do analysis on age, we need to, whatever we're doing, we need to say this is incomplete. This is based on all the data that we have. Similarly, if we look at fair, we're missing 1 fair. I wonder if that means somebody got on for free. I don't know. But that's, I mean, those are the questions that when we do exploratory data analysis, these are the things that we're seeing. We're seeing we're missing values. We're seeing somebody probably was a stowaway. We're seeing, I still don't know what body is. And that maybe I need to go figure out what that is. So yes, there is no right or wrong answer. It is strictly exploring this data to try to figure out what sort of story can we tell with it. And then further down the line, can I use this data to predict something? Like if I made a model out of this and I put in random, if I said I'm a first class person that's the age of 27, I have 2 siblings, and I paid the most for the fare. If I had a model for this, I could put that information in and it could give me the probability that I would survive on the Titanic. So that then is something that provides insight to whomever we're doing work for. Again, bummer data set, but does that click at all? Does that sort of make sense? Like why we would want to do something like this? Cool. I think we're probably at a good stopping point. I would say if you want to, feel free to go through these notebooks. If there's something that you don't understand why it's doing what it is, feel free to shoot me a text or just bring it up next class. We can go over some of that stuff. As this stuff sort of marinades, I know like it's a lot. As it starts to sort of marinate and things might click or things don't click and you want to know why, bring that to class, put it in Slack, let me know. I want this stuff to be usable for you guys. While still, I still kind of want to push some of the foundational stuff as well, because it's important to know when things break, why they break, because you're responsible for fixing that if you're the one doing the code. Cool. Online folks, you guys doing okay? Did I confuse you guys too?
No, this is great.
Cool. Yeah, and again, feel free to browse these notebooks. The Intro to Data Science, you can get all the way, where's one of them has, Anaconda Learning has Intro to Machine Learning. All these notebooks you can just run. Like, you hit the play button. Oh wait, no, play all. Where's the play all button? Run all cells. Hit that. All this stuff is going to run. So here we've plotted some stuff. We have these values. We're doing algebra on this one, sorry. But yeah, feel free to kind of go through all these guys, whether or not you understand it. It's cool to see what this stuff does. And we will get to this stuff too. I don't necessarily know if we'll get to the point where we're running neural networks. But this is also all here for you guys to explore yourself. This entire thing is super helpful. Looks like I'm running 9 kernels. Let's close some of these guys out. Yeah. So yeah, as you do this stuff, you might get stuff going. If this happens, you get to 10 out of 10 and it's mad at you, close out some notebooks you weren't using. You can shut down all kernels. And now we're good. And kernels are sort of like the session, the Python session that's going. Each notebook might have a different one, it looks like in this case, which is kind of weird. But just be advised if you decide to go through this stuff and it starts breaking and you're like, what the heck? What did I do? It's probably your kernel. Yeah. I think we will end it there. Again, as this stuff sinks in, please let me know what works, what questions you have. I want to tailor this course around what you guys want. I really appreciate you bringing up the stuff that like it just wasn't working. I want to change the curriculum so you guys get it. So folks online too, feel free to chime in when something is just not sounding right, or just if it sounds like calculus.
Gotcha.
Cool. Well, I am going to end broadcast, and I will see you guys on Wednesday.
Thanks. See ya.
Yep. Thanks, guys.